This panel is going to be about a new data-first approach. So all of our activities at this point generate data, right? The internet's made us more connected than we have been ever before. When all of our activities generate data, they can benefit from its analysis. And so data is no longer just exhaust that comes out of applications that we look at and analyze post facto. It's the opportunity to build new types of applications. So the main question, of course, here is, well, what are the new applications we should be building? How do we provide value to the business through these applications? So we're going to do a panel discussion on that, but start with 3 perspectives from each of our panelists here, and then open it up for Q&A with the audience.
I'll just briefly start with what is the industrial internet and how it differs from the consumer internet. The term consumer internet was coined 2 decades ago when it speaks to the phenomenal transformation and disruption we've seen in the social media space, and when 1 billion people connected. Now, we believe a similar revolution is happening in the industrial space as 50 billion machines get connected over the next 5 to 7 years. So what are the differences between consumer internet and industrial internet? Is it just people and machines, or is it something more? If you're not able to log into your Facebook account or your social media account, you will probably be annoyed and irritated. But if the power goes off in this room, you could get angry or fearful, or people in hospitals could die if the power goes off. The next aspect is obviously the security. A jet engine in a remote location could be transmitting data. It has to be utterly impervious to security breaches, even as it is transmitting data to a secure location. The last piece is durability. We are building machines that people buy for and last for more than 20 years. So we are looking at building software and analytics with a lifespan that's just absurd in this consumer space. So how does industrial big data look like? We've heard a lot about the consumer world through weblogs and images and such. Let me give you an example of what industrial big data looks like. So this is an example of a jet engine data. In the past, GE used to get 3 snapshots of sensor data, about 50 parameters, from a jet engine. 3 snapshots, whether it was a 1-hour flight or a 12-hour flight, it was just 3 snapshots. Now with the newer engines, we can get up data at the rate of 1/16th of a second and capturing up to 3,000 to 5,000 parameters. So if you think of a 12-hour flight, the volumes, the numbers get big very rapidly. And we have similar industrial-grade machines capturing data at similar rates all across the world. But that's just the volume of data. If you look at the variety of data we take our equipments from cradle to grave. So we have engineering drawings, we have design images, we have manufacturing flow time series data, we have service records, we have quality records. It pretty much covers the whole spectrum in the variety of data that we have. The last aspect I want to talk about, and I usually bring it up, is that big data is relatively a new term brought to the forefront by internet-based companies, but GE was founded in 1892. We have data that's not just decades old, but centuries old. So I think that's pretty interesting. So what do we do with all the big data that we have? We, like any good digital company, we build algorithms. We try to get insights from it and drive positive outcomes for our customers. In a consumer world, if your algorithm is not that great, it results in a bad customer experience, bad online experience. Or worse, your shopping cart crashes. But in the industrial space, we are writing algorithms that prevents jet engine failures or MRI equipments from failing. So if those algorithms are not accurate, those result in flight delays or patient delays. So the impacts are a little bit more significant. So GE has made big investment in big data and big outcomes. We believe that there is a $15 trillion impact over the next 15 years to the global GDP. Just by improving the industries we serve, just by being able to improve the efficiency in the industries we serve by 1%. We call it the power of 1%. So for example, if we are able to improve the fuel efficiency for the railroad operators by 1 mile per hour per day, for his whole fleet of locomotives, it's a savings of $27 billion. So the numbers are pretty huge across the different industries. And I think big data is going to have the biggest impact really in the industrial space. This is where the economies are getting transformed, lives change, we change the way power is consumed. It's truly changing the way we live at a fundamental level. So I think these are big outcomes, one of the biggest outcomes that big data can drive.
I work at LinkedIn, where our business, we are part of the consumer internet. How many of you are on LinkedIn? Everybody, I hope. So our business is data. I mean, we're using data to connect people to opportunity at a massive scale. My particular branch in the engineering organization is to make sure that everybody on there is playing by the rules. That every identity is a real identity. That everyone logging into their account is the person who actually owns that account, and that all the communication is professional. That there isn't spam, there isn't fraud, and various kinds of scams. And we do this using big data, right? We have the data that comes in every second on the site in terms of what people are doing, what normal activity looks like, and we are massive enough, and unfortunately that there's enough bad activity that we have big data on the bad activity too. So we can use that to make predictive models about what is someone going to do, and then use that to stop any of these abuse cases before they happen. So a little bit about how we approach the problem. We think of sort of, I guess someone remarked of defense in depth before. I mean, it's kind of a multi-layer strategy. In terms of you try to stop somebody when they're coming in. If you just prevent a bad actor from accessing the site, if that doesn't work, you can then try to prevent them from executing on whatever nefarious scheme that they have, whether it be spam or fraud or whatever. If that still doesn't, if you don't catch that in real time, then we have a bunch of offline processing that can try to find, aggregate over more dimensions, find more patterns, and clean up, within hours to days after the fact. So we've kind of conceptualized this as systems that work online, having real-time scoring. So the request comes in, it hits some kind of server running some kind of algorithms, and think of this as, say a login request. Is this the person who really owns that account, or is it someone trying to take over that account? So we do some kind of real-time scoring, and then a decision whether to accept and let them in, or reject and block them and store this information. As was remarked before, we don't want to throw away data, especially of what we think is bad actors. So that's stored in some data store of specifically abusive activity. So that's kind of the online real-time world that's running on every request. And then with Hadoop and offline analysis, we get a lot more power. These arrows sort of between the on and offline worlds mean that every day all of the data that we have is snapshotted and extracted to Hadoop, where we can analyze it in aggregate rather than looking at individual requests. And so we can run models and algorithms there to figure out have additional intelligence or processing time to figure out who's being a bad actor, and then ship those decisions back into the online system to actually take action. So a couple of technologies that were built up at LinkedIn. One is Kafka, which is a messaging system. We can put individual members we think are bad into that system and put those back online to be restricted. There's also Voldemort, which is a distributed data store, and that's data that can feed our online scoring algorithms. So it's certainly a virtuous cycle between the offline and online worlds. The challenge here is that there are trade-offs. So offline, you have lots of resources, you have all the data you need, but it takes time for the data to get there. It takes time to run your jobs. It takes time to take action. Whereas online, things are happening in real time, and we've got latency measured in processing measured in hundreds of milliseconds, and it can stop things right there when we need it. And then there's also, if you're also ease of iteration, it's easier to iterate offline because you're not actually touching the production code at the time.
My presentation will actually be pretty short because Eli did a great job kind of creating the question for the panel, and I would like actually for you to listen to all of that instead of kind of listening to me talk about big data. But I'll start with this one slide, which is kind of my favorite slide around big data. Some people, when confronted with a big data problem, think I'll use Hadoop. Now they have a big data problem and a Hadoop cluster. And the point behind it is that, while Hadoop is kind of, almost in many minds is almost a synonym for, a big data solution, it's actually, in most cases, it's not the solution. It's just part of it. And the thing I would like kind of to share, at least my experience with, is the problem that is kind of the most interesting to me, and I've done it now throughout several times throughout my career, is how do I start? And that is, I think, the hardest problem around big data. So, for example, who should be my first hire? Let's say, you think about, hey, I should hire a data scientist. So now at my current company, Salesforce, we just ended kind of creating a career ladder for data scientists, and part of it we discovered we actually don't have data scientists. We have 4 different roles. We have data engineers, who are the people who use tools like Kafka that David just mentioned, or key value stores that are kind of in charge of getting the data to where it needs. There is the data analysts, or also being called decision scientists, that are people who are kind of the main output of their work is kind of dashboards and reports for executives to make decisions. This is an entirely different skill set. There are the, let's say, machine learning experts that kind of build customer-facing applications, who also need to do a lot of coding in order to build those applications. And the 4th one that we discovered also exists in our company. And by the way, before Salesforce, I used to be at LinkedIn, and it's exactly the same at LinkedIn, are what we internally refer to as the data researchers, who are the people who kind of push forward the envelope on what is the latest and greatest technology that we can use to solve the problem. And honestly, those are kind of 4 different, very different skill sets, and you need to know based on your own needs which one to hire. The second problem is kind of, okay, what should be my first project? Let's say, I figured out who are the people I want to start. And that is also kind of, very dependent, but you really have to think about is how do I extract value, and how do I prove that I can have a certain value before I go to whoever signs the checks in your organization and ask for the $2 million that to build a new Hadoop cluster. And this is also the kind of story at my first job. I was the first data scientist at a company called LivePerson, and we started, hey, we have a big data problem, let's use Hadoop. And we actually hired Eli's company, Cloudera, to help us with that. And it was Lars, amazing person, and he came to us and we said, hey, you know what, we have like this 10 problems that we want to solve. And Lars, being the sport he is, and obviously Cloudera is a great vendor, they help us to design a solution that solves all the problem we could think of, the problem we had today and the problem we still didn't have, but we thought we were going to have one day. And we created a Frankenstein monster, honestly. And we had to then kind of scale it back and say, okay, maybe we should focus on one problem that we want to solve and maybe kind of build from there, which is something, by the way, LinkedIn kind of historically done well. So this is kind of the experience I hope to share during this panel is what from my first data science position at LivePerson, where I started. Our data was literally stored on magnetic disks, and we had to big data solution out of it. Then I joined LinkedIn and was part of the data science team that actually coined the term data science and had one of the most advanced solutions in the world, and also working closely with David's team. And now I'm at Salesforce, where it's a very big and kind of very successful organization I'm saying in size compared at least the other companies I work with, that actually has a lot of internal divisions. A lot of them are from acquisition that have their own stack and their own tools and their own data storage. And now we're working in how do we actually make kind of data science work in that environment.